The life and story of Marius Sophus.
Marius Sophus was an influential Norwegian mathematician whose main contribution to the development of mathematics was the theory of continuous groups and their applications to the theory of differential equations, now known as Lie groups. Lie groups and Lie algebras are in the vocabulary of every current mathematician and physicist today. Lie was born on the 17th of December 1842 and lived to the 18th of February 1899. He studied mathematics and sciences at Christiania University from 1859 to 1865, obtaining his PhD in 1871 with the thesis titled On a Class of Geometric Transformations. After his publication, he lectured as a professor in Christiania for almost 14 years. Lie's work, first published in 1869 by the Academy of Sciences, is fundamental to and becoming increasingly important in the work of physics and quantum mechanics today. In 1868, Lie's first scientific breakthrough was the publication of imaginary theory in Crayle's journal, which quickly found success and resulted in receiving a scholarship to travel abroad, where he immediately went to the University of Berlin and began collaborating with Felix Klein on a unified view of geometry, later developing into the Erland program theory. Through the imaginary theory, Lie communicated the idea of the hyperbola rotating on its imaginary axis, regarding the properties of the one-sheeted hyperboloid. It took 3 or 4 centuries before the theory of imaginary numbers became understood in a more natural manner. Though, as a result of this historical trajectory, the designation imaginary numbers has remained, and these imaginary numbers, along with real numbers, make up complex numbers. By analogy with the Cartesian geometry, which is geometry based upon imaginary numbers, became now known as imaginary geometry.
So in simple, Sophus led to the creation of continuous transformation groups. This led to Colchin, Borel, and Chevalier 45 years later developing Lie groups completely algebraically. This is one of the foundations of algebraic geometry and leading to further formation and understanding of differential equations. Lie didn't face many challenges in publishing his work, although he faced other interesting obstacles throughout his mathematics career. While overseas, Lie was arrested in Fontainebleau under suspicion of being a German spy, where his mathematical notes were taken for coded dispatches. He was freed from prison 1 month later with the help of the French mathematician Jean-Gaston Gabot and returned to Berlin. Sophus had many of his works published and was also a part of many mathematical associations in which he could share and contribute his ideas. These included the London Mathematical Society, the French Academy of Sciences, and was also a foreign member of the Royal Society of London. During a 9-year collaboration with Friedrich Engel, Lie published Theorie der Transformationsgruppen, which contains his investigations of the general theory of continuous groups. Lie groups and algebras are the mathematical structure of continuous symmetries used in contemporary physics, which are also tied into quantum mechanics. Because Lie algebras are so restrictive in nature, it makes it very easy to begin proposing alternative theories of nature. So they are a critical tool in understanding theoretical physics. Lie groups and algebras are the mathematical structure of continuous symmetries used in contemporary physics, which are also tied into quantum.
As stated above, this is what Marius Sophus has done for us.